Welcome to Beginning Python. I'm going to give just a minute first to check that everyone's got Anaconda started up and have able to launch it and get it all working. So just take a minute now to start Anaconda Navigator, and if you can, also start JupyterLab. And in just a moment, I'll start going through that myself, and those who haven't got it set up themselves can hopefully follow along and be ready to get started. So the way to start Anaconda Navigator will depend on which operating system you're on. It varies from place to place, but hopefully the instructions that were provided with it gave you the ability to get at least as far as a window that looks something like this one here. So it's the green Anaconda Navigator with the circle and a bunch of tiles on the screen as well. Anaconda Navigator is the way that we are getting access to Python. So Python is provided for free. It is a completely free and open source piece of software. There are lots of ways to get it installed onto your system, but one of the easiest that we found, particularly for these training sessions, is the Anaconda system. So Anaconda provides us with the programming language Python, as well as a bunch of tools which we can use to write and run Python scripts. Some are basic tools and some are very advanced, and you see a selection of some of these on the screen here. For the course today, we are going to be using a tool called JupyterLab. Note that JupyterLab is different to Jupyter Notebook. JupyterLab is a web-based, simple development environment which allows us to write and run Python scripts and more, but that's the extent that we're going to be using it for today. So go ahead and press the launch button on the JupyterLab tile, and I'll do the same, and that should open up in a web browser the JupyterLab environment. Takes a few moments, you see, your web browser should pop up. It thinks about it quite hard, you get spinny things, and then we are here. And with that, I'm going to put Anaconda Navigator away, make this full screen, and nice and big. So you should end up in an environment something like this. If you've already followed through the video explaining how this stuff gets set up, then you'll automatically be left in the environment you last left it in. So it should all be laid out correctly. So the things we're going to be doing in the session today is writing Python scripts and running Python scripts. So there's two different tools that we are going to be using. Firstly, we're going to be using the text file environment to write our Python scripts. So I click on text file, and that has opened up this whole window here as a text file. It's just a text editor. I'm then going to open a terminal. To do that, I click in the plus in the top left, and then at the bottom here, I press terminal. I now have a terminal covering my screen. To make it easier to see everything that's going on at once, I'm going to click and drag on the terminal tab over to the right hand side so that I have the text editor on one side and the terminal on the other. This is all covered in the first video that we sent out, so if anything here isn't working or you've just missed what I did, feel free to have a look at that first video. It's only a few minutes long to catch yourself up. I'm just going to do something which you don't need to do, so ignore this. It's because I've got my files in a special place to avoid confusing things. There we go. So we're going to start off by writing our very first Python script. But before I jump ahead and do that, I'm just going to give you all 30 seconds or so to make sure you're up to speed with this. You've got your text file open, you've got your terminal open, and it looks largely the same as what you see on my screen. Bear in mind, anything you have in this bit on the right might look slightly different, but it's basically the same. Hopefully everyone has now got their environment set up like you see on the screen here. So we're going to go ahead and run our first Python script. So before we can run any Python code, we first need to write some code. So let's go over to the text editor on the left-hand side. And the first thing we want to do, because currently this file is called untitled.txt, the first thing we want to do is rename this file so that it has the correct file extension. So Python file should end with .py, not .txt. And secondly, untitled is a undescriptive name for what we're going to be doing. So if you right-click on the file name in the file browser on the left-hand side and go down to rename, so right-click and rename, and we're going to select all of that text, including the .txt, and I'm going to call it script.py. And then press enter. And you'll see it's renamed here and it's renamed up here. You should also see that the little icon next to it has now changed into the logo of the Python programming language, so we know that it's understanding that this is a Python file. With that, we can go ahead and start writing our Python code. We're going to start with what is probably the simplest Python program you can write, and I'm going to explain the different components that go into it, and from there we're going to build up into more and more advanced scripts as we go through the session this afternoon. So the first thing we do is write the word print, all lowercase and without any spaces before or after the word, and we follow that with an opening and a closing round bracket. This is the print function. Functions in Python are usually lowercase, they can't have any spaces in the name of the function, and a function is called by following it with an opening and a closing round bracket. Some functions don't take any different parameters or arguments, so they don't have anything in between the round brackets. The print function, however, does take arguments, and the arguments it takes are things that we want to display onto the screen. So to give information into the print function, we have to put something in between those two round brackets. So what we're going to put inside there is some words. We're going to ask it to display some words onto the screen. The way that you represent words, or as they're known in Python, strings, is using pairs of double quotes. So if you do a double quote and another pair of double quotes, and then in between them we write hello. So what we have here is the word print, followed by an opening round bracket saying that we are calling the function. Then we have the thing that we're giving to the function, the information that we want the function to process, followed by a closing round bracket to say that we've finished giving information to the function. You'll notice here that the text has been coloured green and red and so on. The specific colours aren't really important, it's just the way that the text editor gives us a bit of information, so it's telling us that it's understanding what's been written. Other editors that you can use won't have this particular colours, they might use blue and red or blue and pink or any other colours in principle. The other thing to note is that the text here is just plain old text. There's nothing special about the program that we're running this in. We can write Python scripts in a basic text editor like Notepad, or you can use advanced integrated development environments like Visual Studio. All of them work in the same way. They're writing simple text files which are then going to be interpreted as Python code. So in order to run this script, first thing we need to do is make sure it's saved. So one way to do that, I think, is to go to File and Save Python File. Make sure you always save your scripts before you run them. Now that we've saved that file, we can go over to the terminal. So we're going to write our Python scripts on the left and run them on the right. To run your Python script, there's a few different ways you can run your Python script, and I went through the options for that in the second video that was linked and it has been posted in the chat. So if you get any errors coming up, go and check out that second video, and that will explain what the other methods are and what kind of error message you might see, and have a go at them, and if that doesn't work, let us know in the chat and we'll give you a hand. But the way I'm going to be doing it on my screen is by running the program Python. So I just write the word Python, ignore the $sign, that's just something that's built into my terminal, that's there by default, you see, that's just telling me that this is a terminal. I write the word Python, followed by a space, and then I give it the name of the script I want it to read, scripts.py. And so what's going to happen here is that this program here, which is called Python with a lowercase p, is going to read the file that I give it, which is this text file over here, and it is going to read that file one line at a time. It's going to look at the text on that line, it's going to interpret it, assuming that it's written in the language Python. Python is a language as well as a program. So as long as we've written some text in this file in the Python language, then the Python program is going to be able to understand it and do the things that we've asked it to. It's going to read it one line at a time and do the things on that line, then read the next line and do the things on that next line, and so on until it gets to the end of the file, at which point it will exit and say, I'm all done, success. So to tell it to actually kick off that process, in the terminal over here, after writing Python space script.py, we just press enter. And we see here it has done what we've asked it to. it has printed. This is a bit of computer jargon. Print in computer jargon generally means display on the screen. It doesn't literally mean print out of a printer. It's a holdover from the olden days of computing, when everything was literally printed out on a printer. But it's displayed the text on the screen, hello, the same as we wrote in our file over here. It has then returned us back to the terminal prompt, the same as it was before, with a flashing cursor, ready for us to run the same thing again. So I'm just going to give you a minute or so now to have a go at doing that yourself. I'm also going to point you at the course notes. So what we're going through here, at the bottom of the first page as a next link, we're having a go at the chapter titled Getting Started here. On the whole, I'm going to be just doing the examples as they are in the notes, and I'll hopefully have Gareth keeping us topped up and tracked as to which chapter we're on. But here we are just going through this very first chapter titled Getting Started, in which we've written a text file and we've run that text file, and then a little bit of an explanation about how that all works, which I've just gone through. So have a go at that yourself, just take a minute or so, and if that's all working, then we're going to carry on in about 1 minute. That should be enough time. Mengdi, so the colour in the terminal doesn't matter at all. Mine is all multicoloured because I'm running ZSH on Linux, which has been set up to be all multicoloured. On most systems, it's just going to be plain black. So if you see hello printed out, then everything's working great. Some questions from Livia and Bryony saying you're getting syntax error, invalid syntax. That's, again, a number of different ways that this can be caused. There's two main types of errors that Python has. There's errors that happen while the program's running, like you've tried to divide by 0, or you're trying to use some information that it doesn't know is there. The other type of error is a syntax error, and that's when your file is written in something which isn't valid Python language. So the first thing to check is that your Python script looks exactly the same as it does over here. That you're using double quotes and not backticks or anything like that. That you're using round brackets and not square brackets or curly brackets. And that everything is in the same lowercase print as you see here. Do you get anything else printed out in the terminal apart from the syntax error? Could you copy and paste the entire thing of you running the script and the output in the chat, and that might help me work out what's going on there. Okay. I see what's going on here. So this will happen if you've accidentally got yourself stuck in the Python interpreter. There's a thing that happens if you just type Python and press enter. So don't do this, I'm just demonstrating. If you do this, you end up in an environment where you've got these 3 arrows here. Now this is like a terminal, but it's slightly different. If you end up there, type exit and then open and close round bracket and press enter. And you should end up back at the non-3 arrow terminal. Once you're back at the normal terminal, you should be able to type Python scripts.py and you should get the text printed out. So I'm just going to clear my terminal on the screen there so that it has a bit more space. Don't worry about doing it yourself, just clearing out what we see. So in Python, there are a bunch of different types of data that you can have. The types of information we've used so far has only been one type of data. We have had a string. They're called strings because they're kind of like a string of letters chained together. It's another bit of jargon which you will get used to. So we have a string here. Hello is a string. Strings are designated by having open quotes at the beginning and open quotes at the end. But as well as strings, there are also different kinds of data types. I'm just going to run the script over here. As a shortcut and a tip, if you're in the terminal and you press the up key on the keyboard just once, it will bring up the previous command you ran. So you can press up on the keyboard and then press enter, and it will rerun that same previous script. I'm going to change this print function here now so that it prints something else. So instead of printing hello world, I'm going to print a number. So 3.14159, that's more than enough digits of pi. You'll see here that the number is green, where the string was red. That's just a decision that the highlighting in this text editor has decided. Again, the colours aren't particularly important. They're just there as a visual aid. You'll notice again there's a black circle here, and I'll point this out in the video, but make sure that before you run your script, you save the file. On Windows and Linux, it's Control S, and on Mac, it's Command S to save the file, or you can go to File, Save Python File. I'm going to use Control S. So now if I run the script by pressing up and enter, we get our number printed out. Okay, so we've got strings, we've got numbers, and we also have integers, which don't have decimal places. That works very well. So if we save that and run that, we just get the number 3 getting printed out. So Sam in the chat is asking, why don't you need quotes for numbers? So the reason for that is Python uses syntax to work out what you're trying to tell it. There are fundamentally different types of data that you deal with in programs. There are words which, as a human, you interact with because you're trying to describe something to someone, like saying hello. And when Python is reading this, it will see the string and it will say, okay, I know that you're not, this stuff inside the quotes isn't special in any way. It's just something that a human would understand, and I don't need to worry about what's inside those quotes. If it sees just, as it's reading along the line, one letter, one letter, one letter, and it gets to here and it sees a number that's not inside quotes, it's going to treat it as that particular mathematical number. And it's important because something we're about to see in a moment, that mathematical numbers in Python you can do maths to. You can do 3 times 2 or 3 divided by 4, and that's going to give you another number. Whereas something like hello, it doesn't make sense to divide hello in quotes by 3 because there's no description of how you divide a string by a number. And so by being explicit from the beginning about what kind of data you're dealing with, it lets Python know what kind of operations can be done to it. A thing to be aware of is that the string 3 is different to the number 3. This one up here, Python will just see as some words which humans understand and it doesn't have to care about. This second one here, it will see as the mathematical number 3 which it can do something with. So anytime you're dealing with numbers in Python, generally you won't put any quotes around it because you want the mathematical concept to be the thing that you're talking about. That said, it is sometimes useful to be able to talk about the types of data you're dealing with in a more kind of abstract sense. So in that example there, we just had a print function and we were just throwing the thing that we wanted to be printed straight inside those double brackets, and it was reading whatever we passed in and it was printing out to the screen. It's quite common to want to give names to your data so that you can refer to it multiple times, or to work as an aid to the reader so they understand what's going on. So for example, 1.3.14, that's good enough. Here we have a Python script which doesn't do anything. It's simply a number. So this here is a piece of data. We can give data names by assigning what's called a variable. And the way that you assign a variable to a piece of data, or assign a name to a piece of data, is by writing the name of the variable you want to create, followed by an equal sign, followed by the piece of data. So this is going to make a new name pi, which contains the value 3.14. This means that later on in our script, we can write print, and instead of writing 3.14, we can go ahead and replace the number literal that we would have put there with the variable name pi. And so when print pi gets read by the Python interpreter, it's going to say, okay, here's some letters. They're not numbers, they're not in quotes, so this must be a variable name. It's going to look up what that variable name is. It's going to see that it's this value here. And so 3.14 is what is going to be printed. So if I save this file and run the script, we see that it prints out 3.14. From the outside, it's looking basically exactly the same, but inside, we've broken it up into 2 parts. The parts dealing with our data and the part dealing with our output. So take a minute or 2 now to have a go at that yourself. Take any print function you want to do, anything that you'd want to print, but break it up over 2 lines. One line which takes that thing that you want to print and gives it a name, and then another line which has a print function which accepts that name as an argument and check that it prints the correct thing to the screen. Be aware that variable names can't have spaces in, they can't start with a number, and there's a few other constraints which you might find as you go along. I've introduced variables. A variable is a way of giving a name to data. And so in your head, it's worth having a sense of the difference between a piece of data, like 3.14, and a variable like pi. They can often be used in the same context, but they're fundamentally different elements of the language. So it's worth kind of working out in your head as we're going through the exercise, thinking about how data and variable names differ from each other. We've always seen a few ways. For example, a string has quotes around it and a variable name doesn't, so they look different, but they also serve slightly different roles in the language. So hopefully as we go through, you'll start seeing how that works. So I'm going to delete all this text and start with something different. So let's make a variable called distance in miles. And you'll see here I've used underscores between the words. There's a convention in Python to write your variable names as lowercase, to use full words in your variable names, and anywhere where there would be a space to use an underscore. Other languages have other conventions, but this is the general convention in Python, and it's the one I'll be following. And let's give it a value 30. So here we just have a number 30, which has no context or no information about it. Because we've got context here in the name of the variable that it says distance in miles, that tells us what this 30 actually represents. And so it's useful when writing Python scripts to give your variables descriptive names, because it will help you understand what the numbers actually mean. If I want to make another variable called distance in kilometers, I could go ahead and just assign this a value. Now I don't even know what that would be, but it'd probably be something like 50 or so. But of course that is not using the computer to my advantage. I could Google it, find out what 30 miles in kilometers is and write the value in here. But a more flexible and reusable approach is to work out what the conversion factor is and to do that conversion ourselves in our code so that we can change one variable and always have the other one automatically updated. And so when assigning a variable, on the right-hand side, you can do more than just write a piece of data. You can also refer to other variables. For example, distance in miles, and we can multiply that by a number. And I'm going to copy the number from down here to avoid errors. So here we made a new variable, and the value of this second variable is based on another one. So then when we print distance in kilometers, and then I save this file and clear it and run it, we see printed out it's 48.2. It's about 50, but it's a much more precise answer. This means that we can come back to our original script and we can change this to be 5,000 miles, and we can find out what 5,000 miles is in kilometers just by changing one number, rerunning the script, and we find out that it's about 8,000 kilometers. So this is starting to show the value of using variables rather than hard coding your numbers. It's also showing you how you can use variables which are based on other variables. As well as multiplication, there are other mathematical things that we can do. So I'm just going to copy and paste this one from my notes down here. No one wants to sit here watching me type all day. And so here we have a variable which is a floating point number, a decimal place number on the right hand side. We're making a new number which is that plus something, and then we're printing that out. In Python there are 4 primary mathematical operations you can do. Plus, well, uses the plus sign. Minus uses the minus sign, as you would expect. For multiplication, it uses a star. And for division, you use a slash. So those are the 4 primary different types of operations that you can do to mathematical numbers in Python. Going back to Mendy's question earlier about why some things are in quotes and why some aren't, I'm going to show you an example now of how Python sees the differences between those two types of data in the program. So I'm going to make a variable here, and I'm just going to call it my underscore number, and I'm going to set it to 67. And I'm then going to say my other number equals my underscore number plus 100. And then I'm going to print my other number. So we run this script, we get the kilometre thing and the Celsius thing printed out, and we get 167 printed. So it's successfully printing out the thing that we had. If, however, we put this 67 in quotes, Python is no longer seeing my number as being an integer. It's no longer seeing it as being a mathematical object. It's seeing it as being a text type object. And it doesn't know how to do mathematical things to text objects. So if we now run our script, we will see the first of our Python errors. It is unable to do the addition operation because it's no longer doing it to two numbers. It's trying to add a bunch of letters and a number together. And it's going to say that it's assuming that you made a mistake. It's not going to just implicitly convert something. It's going to make sure that you're going to be explicit about what you're doing. And so if we look at the error over here, the way that I read Python errors is by starting on the last line. It says type error. So that's telling it it's an error to do with data types, where types are things like strings or floats or integers. The error message itself is saying it can only concatenate strings and strings. Remember, this is a string, which means that my number is a string, which means that we're doing my number, which is a string, plus an integer. And so it's interpreting this as us trying to take one set of letters and stick another set of letters on the end. And that's what concatenating string to string would mean. Concatenate means stick next to each other. However, it's finding an integer, and so it's saying, I don't know how to do that, and so I'm going to bail out and stop. And when you get an error like this, the program will stop running, it will return you back to the terminal, and it will print an error like this on the screen so you can work out what's going on. So always start with the last line, because sometimes that's enough to let you know exactly what you did wrong and to let you know what's going on. If you've got a long program where your errors can crop up in all sorts of different places, it's worth looking at the lines above, which tell us where the error came from. This line here tells us which file we were on, which line we were on. We see it's on line 14. This is why programmers always have the line numbers turned on in their text editors. And then this line here in the output is the exact line that we had in our text file to give us context to let our brain jump back to the error a little bit more quickly. So with that, I'm going to ask you to have a go now at the exercise at the bottom of the data types chapter. So there's an exercise there to edit script.py so that it's made up of adding two strings together. So originally it said hello Python. In fact, I'll show you how it looked beforehand. It had something like my words equals hello Python, and then it was print my words. It might have had a different variable name, but that is not important. So have a go at taking this little program here, but breaking up this line here into two separate variables, one which has the word hello in, one which had the word Python in. Make a third variable, which is those two things added together, and then print that out and make sure it looks how you expect. Once you've done that, carry on to the end of that data types chapter. There's a section there on printing multiple things. So have a go at that, reading through that, and having a go at that exercise as well. Mengdi there has a question about, is there a difference between my underscore words and my words, with or without the underscore? So the first thing I would say to that question, Mengdi, is the best way to find things out is to try them for yourself. You will often discover something really interesting if you have a go with something and it works or doesn't work how you expect. That said, I will go through that with everyone because I think it's an interesting thing to look at. So here we made a variable called my underscore words. If I delete that underscore and put a space and put a space here, and then we try and run this script, I'm going to clear this and run the script, we get a syntax error. And the reason we get a syntax error on that first line is because Python starts reading at the beginning of the line, it sees the word my, and that's a variable name by itself. So the only thing that's able to follow a variable name by itself at the beginning of a line is an equal sign. It only makes sense if you're immediately following it to assign this variable a value. Because it sees the space as a break between two different variables, it's expecting there to be an equal sign next and not a space and some words. So this is telling us, the fact that we get a syntax error here, that my space words doesn't get seen by Python as a single thing. It gets seen as two separate things, a thing called my and a thing called words. And because they don't make sense next to each other, it's not understanding what you're trying to say here. So we need to put an underscore in. Sorry, an underscore. If we try that again, we'll probably still get an error. We do, but this time the error is on this line here because the same thing's happening. As an argument to the print function, it's expecting a single variable name. Here we're giving it two variable names separated by a space. It doesn't know what that means, and so it's going to give us a syntax error. So we need to have underscores. We could do it without any underscores at all and no space. That would work perfectly fine as well. The underscores are just there for visual clarity. Okay, so I'm going to show the answer to that exercise you were just working on. Hopefully you had a chance now to have a go with it. So as I explained to Mengdi, underscores are used for visual clarity and you can't use spaces in place of them. So we have our string here. We are going to change it into word 1, which is going to be hello. It's going to be word 2, which is going to be Python. And then my words is now word 1 plus word 2. We save and run this. And we see hello Python printed to the screen. The last section on that page was taking this example and making your life easier. You'll notice that you had to put a space here because when you add strings together, it doesn't automatically put a space in for you. If we get rid of that space and run our script, we get hello Python, all one word, which is not usually what we want. So what we can do with the print function is get rid of this line entirely and simply print word 1, comma, word 2. The comma here is telling the print function that we're giving it two separate variable names. It will take one, it will print it, then it will do a space automatically, and then it will print the second argument. So if we save and run this, we get hello Python back again. With that, I'm going to move on to the next section. At the bottom of that page there, if we press next, and we go down to the bottom, we press next, we end up on a chapter called lists. So this is when we start getting a little bit more interesting with things. So far we've been dealing with single pieces of information, a single number or a single set of words, a single string. But quite often in real life, and therefore quite often in programming languages, you want to deal with something that contains multiple objects. The example I always come back to that I think most well represents real life is a shopping list. You go to the shops and you have a list of things written down on a piece of paper. You have one shopping list, but inside that list you have a set or a list of items that you want to buy. You can think of each item as a string, but we need in our language some way to describe the list as a whole. The way we do that in Python is with a thing called a list. A list is a built-in type in Python, and it's what's called a container. It contains other pieces of data. So I'm going to switch back over to my editor, and I'm going to make a new file. So I'm going to go to File, or not File, I'm going to click on the launcher, and put it here, and make another text file. So I've still got my old file here, but my new file here, I am going to rename it to list.py. So it's called list.py at the top, and then we can go ahead and close script.py. We don't need that one anymore. So I'm going to go ahead and make one of these containers. Like anything else, we start by giving it a name. You almost always want to give your variables names, and this is a really good way of making sure that you understand the kind of thing that's inside it. Same as before, we follow it with an equal sign because we want to give it some data. In the past, we would just write a number here, or a string, or do some kind of numerical work on some other data type. To make a list, we use square brackets. And I'll point this out at this point, that in Python, there are lots of different types of brackets used in different situations. It really matters which type of bracket you use. So far we've used round brackets for calling functions, and here we're going to use square brackets to create a list. In between those square brackets, we put the things we want in our list. For example, cat, that's a string. We follow that item with a comma. Notice the comma's outside of the quotes. Dog, and let's put a number in as well, 261. So you see here we've got one list, one object that has 3 pieces of data inside it. Penguin, yeah, let's do a penguin as well. Thank you, Gareth. Penguin. You can have as many items as you want in a list. It's not limited to just 3 or 4. You can have lists with thousands of items if you so wish. You can also have lists with no items in. If we write it like that, that's a list with no items in. When we print our list, we can print it like any other variable. My_list. What's going on there? There we go. And we run it with Python list.py because our script is now called list.py. Run that and you see it's printed out the things that we put inside our list. It's got the square brackets printed out on the output to remind us that this is a list we're printing. It's got commas separating each item, and it's got quotes showing that these are strings. You'll notice that when you print it out, it uses single quotes, whereas when we made it, it had double quotes. That's because in Python, single quotes and double quotes are almost interchangeable with each other. There is a subtle difference between the two, but largely they mean the same thing. The convention is usually to use double quotes when making strings. However, regardless of what you make your string with, when it prints out, it will print with single quotes due to an older conventions. You know what conventions are like, they change every week. So have a go at that yourself. Make a list with some items inside it. Try putting some strings in there, some numbers, some floats, all sorts of different things. And make sure that you can print it out and it shows up on the screen correctly. Okay, so hopefully you've all managed to print a list out and that's all working for you. So we're going to move on and do something a bit more useful with a list than just making a block of a list and then taking that whole list and showing it to you on the screen. With a shopping list, you don't just deal with a shopping list on the whole, you deal with the items inside the shopping list. And so we need a way in our language to get access to the items inside. So we're going to make a new variable called myElement. Element is jargon generally for an item inside a list. Though the jargon isn't really consistent and you'll see it change later, but nonetheless it's often used for that. To get an item from inside a list, we write the name of the list and we follow it with square brackets. These square brackets that immediately follow the name of a variable are different conceptually to the square brackets we used when we made the list. If you've got square brackets by themselves with a space beforehand, that's you making a new list. If you've got square brackets and they immediately follow a variable name which is a list, that's you accessing things from the list. It's you asking a question of the list. We can put something inside those square brackets, kind of like a function call, to tell it what piece of information we want. So we can write, for example, number 1. And we want to not print the whole list, we want to just print that one element. So, audience participation time for those who are listening. Who wants to let me know in the chat what's going to get printed out when I run this script? And don't be shy. Okay, we've got some cats and some dogs. So those who are saying cat might be confused about how it could possibly be dog. Let's run it and find out what actually happens. We do indeed get dog. The reason for that is that in Python, everything starts counting from 0. When you're talking about elements in a list, the first element is actually the 0th element. This is item 0, this is item 1, this is item 2, and this is item 3. Everything in Python starts counting from 0, and it is very consistent with that, and so it's a thing that's worth remembering. If we change this to myList 0, at this point we should indeed get cat printed out. By that logic, if we want to get penguin for Gareth there. If we do it with number 3, we should get penguin printed out. Next, pop quiz. What happens if I put in 7? What's going to get printed out here? Any guesses? Great, everyone's telling me that it's going to print an error. I expect by this point many of you are used to seeing errors because Python does throw them at you quite readily if it thinks you've done anything even slightly wrong. Over time you will learn to appreciate and love Python exceptions and errors, but when you're learning it can feel like you're being told off. The thing to remember is that it's just trying to tell you that it doesn't understand what you're telling it, and that it's thinking you might have made a mistake and it's trying to give you the information you need to fix it. Let's run this and find out. We do indeed get an error. Like before, we start reading at the bottom line. It is an index error. It's called an index because this operation with square brackets is sometimes called indexing. The actual text of the message here, list index out of range, is telling us that the list, my list, the index we're asking for, 7, is outside of the range of valid numbers. We only accept numbers from 0 to 3, so 7 is way out.
5 is right out.
And so it's going to give us an error. There's no valid answer we can give here. Notice that because it failed on line 3, which is here, the program stopped running. It didn't print an error and carry on. It stopped entirely. It never even tried to print my element. As soon as you get an error raised, the program just stops at that point and tells you what it knows about its state at that moment. So we know that 7 doesn't work, but 3 does. So far we've dealt with 0, 1, 2, 3. Those all worked. We've tried bigger numbers, 4, 5, 6 and 7. Those don't work. What do you think happens if I put in negative numbers? -1. Who wants to have a guess about what -1 is going to do? Costas thinks penguin, and you're not sure. Ricardo's guessing the same thing. Let's find out. Let's run it. We do indeed get penguin. We get the last element. So the designers of Python realised that all the positive numbers, including 0, if you count 0 as a positive number, are potentially valid inputs, depending on how big the list is. But you would never have any meaningful meaning applied to a negative index. It just doesn't make sense because we are counting. We aren't dealing with mathematical comparisons and so on. So they realised that because all the negative numbers are free to be used and they don't have any ambiguous meaning, you can use negative numbers for whatever you want. And they decided that -1 should mean the last item. And in fact, beyond that, negative numbers just count backwards along the list. So -2 will give us 261, -3 will give us dog, and -4 will give us cat. If we try and go to -5, we'll see that once again, we get an error. I'm just going to clear my screen up so that it doesn't disappear off the bottom. -5 gives us an error because indeed there's no negative things over here. It doesn't just loop around forever. It's bounded by the size of the array. The last thing I want to show you on this section, which comes to Rachel's question, and I'll come to your question in a moment, Rachel, once I've covered the basics of slicing, and that is, so far with indexing, we have simply selected individual numbers. We've asked for this element, or another element, or we've asked for something which doesn't exist by going off the beginning of the list or off the end of the list. It's quite common with lists, or with any kind of a container which has things in an order, to want to grab a selection of items. So let's say we wanted to select items dog and 261. We can do that by using what's called a slice. It uses the same kind of syntax as we have here. So we still use the square brackets, but inside the square brackets we tell it where we want to start selecting from and where we want to end selecting from. So we want to select from here to here. So dog is item 2, and we want to go as far as, but not including, penguin. Dog is item 1, see, even I get mistakes. And we want to go as far as, but not including, penguin, which is item 3. The way I like to do the numbers here, because 1, 3 doesn't intuitively say to me those 2 items, is that I count the commas in the list as a way to remember what numbers I should put here. I imagine there's a 0th comma here because 0 is invisible, so there's no comma. So this is comma 1, this is comma 2, and this is comma 3. So if I want to select from this comma to that comma, I do 1, 3, and that's going to give me this slice of the list. So when I print this, I get dog and 261. It's this subset of the list. Now, coming to Rachel's question, she asked, is there a way to get, say, the last 3 elements? Because if you do -3, -1, it will print the last 3 and 2 elements, but not the last element. Okay, so let's work up towards that question. So here we've got 1 and -3. If you remember earlier on, number 3 referred to penguin, but also number -1 referred to penguin. So we can replace that 3 with -1 and say we want to go from comma 1 to comma -1. A little bit confusing, I know, but the more you do it, the more you'll get used to it. So this is going to give us that same set of numbers. Likewise, this is comma -1, -2, and -3. We could change this to be -3, -1, and we print this, and we get the same bit of information. Now, Rachel was asking, how can we get it to include penguin as well? If we change this to a 0, that's not going to work. It's going to try and go from here to here. There's nothing to represent this comma at the end. It's going to try and go backwards. And in fact, if we try and do this, it will give us an empty list because we've tried to index backwards, and so it's just going to fail. If we want to go right to the end of the list, there's a special shorthand, and that is you just leave that space there blank. You say go from -3 to infinity, effectively. And so when we run this, it's going to do dog, 261, and penguin. Likewise, if you do a blank at the beginning, it represents the beginning of the list. So just a colon by itself inside square brackets means right from the beginning until right at the end. So have a go at these exercises on this page here, the lists chapter. So get through as far as the slicing section if you can. The last thing I wanted to cover in this list section is how you can go about changing lists. So far the lists we've made have been static objects. They haven't had anything changing in them as we've been using them. But of course, lists are most useful if you can use them to collect information as you're going through your program, collect information in them, and then do something with that information at the end. So let's change our list here so it just contains animals. Let's delete this my element thing because we're not going to be grabbing something out of it, and let's print my list. This is now just going to print cat, dog, penguin. Let's pretend that what we're doing here is making a list of the animals that we have on our very strange farm. It's got cats and dogs and penguins. Maybe it's our pets. Maybe we've got a pet penguin. Maybe we're that lucky. In order to add something to a list, we write the name of the variable and follow it by a dot. After the dot, we write append. Append is a function, and so it takes brackets to call the function, just like print does. Inside those brackets, we pass an argument, which is the next thing that we want to add onto the list. Someone give me an example of an animal to add in here. Rat, there we go, wonderful. So when we run this, we will see we get cat, dog, penguin, and rat, all our pets. So what's going on here is we are referring to our list. This is the object, this is our data container that we have. By writing .append after it, we are calling a special kind of function, which is often called a method. That's just a bit of technical jargon, but they are relatively interchangeable terms, method or function, on our object. So the fact that it's a dot followed by the name of the function says that this function is going to be affecting this piece of data. And depending on what the append function does, it is going to take whatever's passed in and do that thing to my list. In this case, the append function takes whatever is at the end and takes whatever is passed in and adds it to the end of the list. Emma is asking, how do you add rat to be the second in my list? So there's two ways of interpreting that question, and I'll try and cover both of them. One is that maybe you are asking how you can overwrite the second item. So maybe you want to take what would be dog, second being number 1, remember, and you can assign that to be rat. This is going to take this list, then it's going to find my list 1, which is dog. It's going to overwrite it with rat. If we run that, we see that dog has become rat. If, however, you want to insert it into the list, this is where I can't remember everything. I believe there is an insert function. Let me just Google it, because that is how we learn. Python insert list. It's into the Python 2 documentation. We want the Python 3 documentation. Here we have the list.insert function. It takes 2 arguments. The first argument is the position, and the second argument is the item. I can never remember which way round they go. So we want to insert at position 1, and we want to insert rat. So when we run this, we see cat, rat, dog, penguin. Hopefully one of those 2 things is what you are asking about, Emma. So if everyone's okay with lists, we can loop over them, we can grab items out, we can change things to do with them by appending to the end, and as we saw there, overwriting or inserting. So after the list section, we are on loops. So hopefully as we go through this, Olivia, I will explain the answer to your question, and I'll just read it out now so that I remember what it said. At the beginning of the loop section, you assign 2 variables called word with different strings. So does the variable store all the data that you assign to it? Okay, so I will go through that now. I didn't realise how soon it was. So let's make a new file, and let's call it loop.py. New file, text file, rename, loop.py. So the example I start with is writing something like, we've got word, hello, we're coming back to our examples from the beginning here, and then we print word. We run that, print hello, of course it does. We've done that several times so far. I think we're all comfortable with printing and variables now. If we want to print 2 things, we could do word equals Python, and then print word. When we run this, it runs line 1 to assign the variable, runs line 3 to print out hello, then runs line 5 to assign a variable, and then it runs line 7 to print hello. Olivia's question there was we have assigned the variable word with the data hello, and then a few lines later we've assigned the same variable name with a different piece of information. What happens at this point in Python is that Python will forget anything about the history of the variable word. It will no longer know anything about the data hello. It will just know that word equals Python. Anything to do with hello from this point on in the program would be lost. It has no memory. It just remembers the most recent thing that you've done to it. The reason we get both hello and Python printed out is because we printed this one before we assigned the variable. This is one of the ways that variables in programming and variables in maths are different from each other. In maths, if you say something like a variable equals a number, you're stating some kind of mathematical fact that is then going to be always true for the rest of your analysis that you're doing. And so saying that word equals hello and then word equals Python doesn't make sense because it can't. A variable in maths can't have 2 different pieces of data associated with it. In programming, however, because we're going through sequentially, it does one and then it overwrites it with the second. The second thing that I hope you're all thinking about this little bit of code here is that it looks very repetitive. We've basically written 2 lines of code and then written exactly the same 2 lines of code with one tiny little change. Every time we see something being repeated like this in a program, we should always think there's got to be a better way. Programmers are lazy. The best programmers are very lazy because they make the computer do the work for them. So let's get rid of this. Let's make this a variable words, and let's make this into a list. So here, instead of 2 variables and printing one at a time, we've got one variable, which is a list which contains 2 pieces of data. And we're currently printing the variable word, which previously was referring to one word and then the other. But what we have here is a container, a list. What we conceptually want to do to this container is for each item in that list, we want to print that item to the screen. When you want to do something to each item in a list, we use a thing in Python called a loop, or in this case, it's called a for loop, because we are doing something for each item. And so we introduce that using the word for, and you'll see immediately it goes green and bold in our editor here, so we know that it's understanding what we're writing. I'm going to write it out and then I'm going to explain what these different parts mean. So the way I like to think about the structure of a for loop is first we just look at this line up here. This is the part that introduces the fact that we are going to be repeating ourselves. There's 5 different things in this line. 1, 2, 3, 4, and then the colon at the end, number 5. In every for loop you write, the for, the in, and the colon are always there, always in that order, and always spelt exactly like that. Those are the fixed scaffolding that we use to construct our repeating for loop. The places that we have flexibility and artistic license inside our for loop are in the other 2 locations, here and here. I'm going to start with the second of those, between the in and the colon. This is where we write the thing that we want to loop over. It is the thing that is the list that contains items that we want to do something to each item of. We want to do something to